Hello everyone, so welcome back. So for this video, we're mainly going to talk about how to get a confidence interval for a mean. And so when we had started this handout, we had talked about these two different goals of using a model for prediction, which we've already talked about, or of being interested in like parameters in a model. And so like we might want to know what the mean GPA is for this example, which is the example we're about to discuss, or we might want to do a hypothesis test, which is what we'll cover in the next video. So I'm jumping over now to page 6 of this packet, which is where we left off, and we're going to continue to use this GPA data. So given here in this problem description are the sample standard deviation and how many students there are in the data set. And now we're just going to suppose that, well, the administration has a goal to find out what a reasonable range is for the average first year GPA at this school. To answer the administration's question, then we're going to find a 95% confidence interval for the mean. And so let's follow our usual prepare, check, calculate, and conclude steps. For the prepare step, we're going to start just by rewriting what the population model is, and we're just going to do this quickly since this was covered in a different video. And we're going to rewrite what our fitted model is. And so remember our sample mean was 2.47. So for now, since we don't have any predictors, that's just what our fitted model is. In terms of notation, we're going to write our sample mean either as a mu hat or as x bar, so a little x with a bar. Those are both pretty common notation. We'll run into both. Our sample standard deviation, which I'm going to grab from this problem, we're going to denote as S. And our sample size n is 1,000. Okay. And so now for our check steps, there's again going to be an independence condition, which is just really asking us, okay, is each case giving us like new information? And in this case, we could think about each student as providing us with a different GPA, giving us really kind of new information for this problem. So we're going to say independence holds. For the normality or sample size condition, as we've sometimes called this, we talked about the condition for the sampling distribution to be normally distributed for quantitative data. And our condition was either we had a small sample size and there was no skewness or outliers, or we have a large sample size, which is what we have here since we have 1,000 cases. And as long as we have this large sample size, then we're just saying, okay, we're good as long as there's no extreme skewness or extreme outliers. And so to make that assessment about skewness and outliers, I'm just going to flip back to the beginning of this note packet where we had this histogram. We're seeing that, okay, it is a little bit left skewed, yes, and there is one outlier here, but they're not really extreme. So we're going to say that we're good to go. For our degrees of freedom, we've talked about, in this case, it's going to be our sample size minus 1. And so we've got 1,000 students, so degrees of freedom is going to be 999. We're going to end up using those degrees of freedom on StatKey to get this T star value that we'll use in this confidence interval. And so just like we did for proportions, I'm going to draw a distribution, and this time it's going to be a t-distribution if we want a 95% confidence interval, that means I want to find this t star value so that 95% of the area in this curve is in the middle and 0.025 are on the tails. So 0.025 on each tail. The value that we're looking for is this t star value. And we have to use some sort of technology to get that value. And so what we're gonna end up using for this is StatKey. And so you could go to StatKey, click on our click on our announcements, and the sites that we use in class should have a link to the t-distribution in StatKey. What you would do is enter the degrees of freedom, 999, click on the little button in the top left that says to tail, and then change it so that the middle area is 95%. That will give you the t value, or the t star value for this confidence interval, which is just going to control how many standard errors we go away from the mean when we make our interval. So t star, take a moment to kind of think about these two questions. Would that t star value be different if our sample size was different? Would it be different if our confidence level was different? So for sample size, yes, it is going to be different because degrees of freedom are going to change. And degrees of freedom we talked about in that t-distribution video, that's what really controls the shape of that t-distribution. For confidence level, yes, it will also change that. We would be shading a different region. So going back to our picture here, if it was a 99% confidence interval, that's going to kind of bump these values out and our t star value is going to be bigger. If it was 90%, that's going to mean just 90% of the area of the curve is shaded in the middle. That's going to push the t star inward, and t star is going to end up being smaller. So if you go ahead and check on StatKey, you should be able to find this t star value is 1.9623. You might recognize that that's pretty close to 1.96. And because our degrees of freedom are so large, the t-distribution for large degrees of freedom really just starts to look like the standard normal distribution. So that's why it's so close to what the z-star was for a 95% confidence interval. Okay, so that's kind of the hard part. From here, it's just kind of plugging stuff in. So remember x bar or mu hat, whatever you prefer your notation for the sample mean to be. And then we're just going to add and subtract our t star times our standard error. And so for this example, I'm going to plug in everything that we wrote out in that prepare step. If you calculate all that out, you should get an interval between 2.424 and 2.516. Finally, we want to be able to interpret this interval. And so our interpretation for the confidence interval is going to sound really similar to when we interpreted these intervals for proportions. So we just want to say we're 95% confident that, and now instead of saying that the proportion of something is between two different bounds. We're just saying that the population mean is in between two different bounds. And so I want to put that in context of the problem as much as possible. And so I'm going to say that the true mean GPA at this unnamed college is between 2.424 and 2.516 points. And that's it. So that's giving us a nice range of plausible values for what the true mean GPA of first-year students at this school is. Blurg, we passed the 10-minute mark, so sorry about that. But as always, let me know if you have any questions. What we'll do in the next video is complete this hypothesis test.